I'm CK. Tonight I have what I think will be a fun little kit. It's from DIngdong, which I bought. I've done one of their kits before out of China, and this is a digital temperature sensor. Might be kind of fun to have around in the shop. We'll put it together, see how it works, and I hope you enjoy the video. Here's the bag. DIngdong store. Digital thermometer, 0 to 99°C, 32 to 210 Fahrenheit. Make electronics. Jumpstart your journey of electronics. Warning, some products are parts that need your own soldering. In other words, it's a kit. We're not responsible for failure due to improper soldering. Small components, keep away from children, so on, so on. Oh, suitable for children over 8. That's nice. I think children over 8 are very appropriate to start thinking about things like this. Again, I've done one DIngdong store product before. I thought it was kind of good. Of course, as typical, I can't get the freaking bag open, so we'll just hack at it. Let's see what we have. Circuit board, pretty basic. It's got a digital display, 1, 2, 3, 4 transistors, some resistors, something that might be a bus connector for something else, I don't know. One big controller, a voltage regulator, resistor, 12 megahertz chip, speaker, some capacitors, a couple of buttons, switch. Pretty straightforward. And as we look at the back, the traces are very, it's single layer board. Traces are very clear if somebody's learning and they want to follow a signal like from the power. So the power comes in here. It says DC. It doesn't say how much DC, but I spy a USB cable in there, so figure 4 to 5 volts DC. So you could follow all along if you want and see how the power bus runs, where the ground plane is, all that kind of stuff. And the values for all the components. Oh, I know what this is. I bet this is that the inline resistor package for the LEDs. I've seen that before. You can see that in a video of mine from about 2.5 months ago. I'll see if I can remember which one it is and put it in the description. I think it was the speaker one of the speaker kits that had LEDs in it. Okay, so that's the circuit board. I'm going to go ahead and look at the piece of paper that comes with it. Soldering tips, component list, product feature, digital temperature line based on a 51 single chip microcomputer and temperature sensor DS18 Baker 20. So it both displays temperature and it can set an alarm for it. And here are the steps. Very simplistic. Then the operation, and a nice schematic which describes the chip and how it talks to everything. And that will be fun. So that looks pretty straightforward. Let's look at the parts themselves. There it is. Yeah, that's the little resistor package. One of the pins is already bent. Inline resistor package, there's a bunch of resistors in there. USB cable. Something that they want to protect in here. Oh, that's the digital display. Here is either a transistor or voltage regulator. That's a voltage regulator. Here's the big old chip. It's the Atmel AT89C51, a common microcontroller. Some resistors, and they actually have their values printed on the paper strip, which is nice. Some wire. I don't know what the wire is going to be for. An LED. Some probably truly horrendous solder, which I won't use. Bag of the components, the timing crystal, electrolytic cap, power connector, switch, one 4-pin pin header, that's interesting, and some disc caps. In here we've got little switches, and this is the transistor. And one of these, and there's a little buzzer. These crappy little buzzers are everywhere. And one of these is the temperature sensor, but I don't know. That's the 559s. I don't know which one that is. DS18B20. Let's see where that is. Oh, there it is. I think. No, that's the power connector. Now I'm just mumbling to myself because I can't find it. Believe, let me double check the part number here. Yeah, this is the 18B20. This is the temperature sensor. So that's it. A pretty, almost forgot one other little guy. Don't want to forget the other transistor. So pretty straightforward, looks like. And again, I don't know what this wire is for. Let me take a look at this. No, I don't see. I don't see what the wire's for. But we'll keep it around. Maybe we'll run into some reason to use it. We'll go ahead and get the soldering iron heated up, and we'll put this thing together. We'll start. For those of you who've looked at my channel before, you might notice something new here. I have a new silicon rubber soldering pad, soldering support pad, and with whatever. And I made this just today. So if you go back to my channel and look up CK Builds a soldering silicon rubber soldering holder, you'll see how I made this. You may want to do it yourself. I find it very handy. It's also very heavy. So we're going to start with what the manual says, and it says put the 2K2 resistors on, and we can count 1, 2, 3, 4, 5 of them, and that's 1, 2, 3, 4, 5, 6. 2, 4, maybe there are more. And there's a second strip. Yes, there's a second strip. So there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's probably too many. they do sometimes give you extra parts. 1, 2, 3, 4, 5, 6, and that's all. So we've got 4 extras to put in our spare parts bin. It's one thing as you go along, developing your soldering skills by doing kits like this. You'll find over time you accumulate a lot of spare parts that are very handy when you're looking for something later on, or you get a damaged part or something like that. So when we're doing resistors, the first thing we want to check is to see how far you have to bend the leads in. How close to the body you want the leads to be so they meet the holes in the board just right. And this one, you have a little bit of distance, maybe 1 millimeter out from the body, and then put it on. Now I just pulled that resistor back out, and let me show you why. My style is to have the value bands on the resistor pointing up if they're vertical, or to the left if they're horizontal. There's no requirement to do that. I just recommend that you pick one methodology. So you're not doing some this way, some that way, some that way, some that way. Much easier to find problems later on if you lay your components out consistently on your circuit board. Let me go ahead and see if the circuit board takes solder well, and it sure seems to. So this will be easy to solder, no worrying about fighting about the solder sticking. So that's 2 resistors. I'm going to go ahead and put the cameras in fast playback and put all the rest of the resistors on the board, because there's not much more to say about them. So we'll speed through getting all the resistors on the board. That's the resistors. And now we're going to put the 4-pin, what they're calling the 4-pin socket, at J1, which is here. And this is actually the pin header I spoke about before. This is an external connector that you could, as you can probably see, put positive and negative voltage in, and then there's a reset and a trigger pin to pulse the chip and control the chip. I'm actually not going to put that on because I'm never going to do that. So we don't need that. That's not necessary to make this kit go. It's for expansion if you want to connect it to an Arduino or Raspberry Pi or something like that, and we're not going to be doing that. Now we'll take the 10 microfarad electrolytic, double checking, and it's polarized. Long lead is positive, and there's a slight shading here indicating the negative side. It's not very well marked, and the instructions say the longer pin is positive facing down, which I assume means that way. And we'll do the 2 30 picofarads. Looks like they gave us extra of those too. Gosh, a whole bunch of extra parts in this kit. That's nice. Again, if you are just starting out, get yourself a box or a shelf in your room or in your workbench where you can keep all these parts that come extra. They will be very handy throughout the rest of your building career. It's always good to have spare parts, because many parts like these, the 10 microfarad cap or these 30 microfarad disc caps, they're commonly used, and having spares in case you get a kit that doesn't have extras but in fact is missing some parts. I had 2 kits last week that came in with parts missing, and fortunately I have plenty of spares that I've collected over the years, bought or came extra in kits or something like that, so it didn't stop me. I was able to just grab a spare and move on. Now there's a diode that goes here, that red diode. Let's see if it works, because diodes can be a little bit flaky sometimes. So let me show you how to test a diode to see if it's working, and if it's a clear one. You may not know what color it is, so this will show you that. Get your meter. You do have a DVM digital meter, right? Set it to continuity, which means when you touch the leads together or you put it across a conductive surface, it'll beep. Now what that means is that there is current running through it. Just a little bit, but it's enough that if we put our positive meter lead on the positive leg and the negative one, see, the LED lights up. So we know the LED is good, and we can move forward with putting it in without worrying about having to replace it later with a different one. Now again, long lead is positive and it will go down because the silk screening shows the flat spot for the negative or cathode side of the LED. What do they want us to do next? Now we'll put the 12 megahertz crystal. This is the timing crystal. It goes over here at Y1. These are also not polarized, so it doesn't matter which way you put them on. The next step is to put the 4 transistors on the board. And of course, transistors matters quite a bit how you install them, so. But they're easy. Flat spot on the transistor goes to flat spot on the silk screening. And if you just do that, you won't have any problems at all. Okay, now we're going to put the switches on. These are little standard clicky type switches. You can only put them on one way. I mean, one of 2 ways. You can put them on this way, but you can't put them on that way because the leads won't go in. So again, you cannot, or it's very difficult to get them wrong. So just push them through. And because of the way the leads are bent, they stay in place very easily, so you can solder them very easily. Now we'll put the DC power supply connector on. right here, and the way the legs are positioned, you can't position that incorrectly either. They generally, electronic parts manufacturers work really hard to make sure you can't get things wrong. So if you're just beginning your journey here, everybody from the guys who make the parts to people who lay out circuit boards, everybody wants you to be successful. Okay, so now we have the other switch. This is the power switch, master power switch, because it clicks on and clicks off. One thing they don't give us is they don't give us a little cap for that, but that's okay. I'm not going to complain too much about that. I bridged two contacts there because I have too much solder on my soldering iron. So all I do there is I take my little solder sucker thing, heat up the solder, suck it back out, and now redo those connections without bridging them. There we go. No matter how many times you've done stuff, you will make mistakes. Now we put the little speaker on, and this is polarized. You can see the positive symbol there above this leg, and there's the positive symbol on the circuit board. Now this is up a little bit. As you may be able to tell, the board is at a little bit of an angle, so I don't have the speaker flat against the board. See, you can see it's up. So what I'm going to do, I've soldered one leg, but I'm going to put pressure on it with my index finger, heat that solder up, and you heard it click. Now it's flat on the board. That's why when you're putting something like that you want particularly flat on the board, you do one leg at a time, or one leg first, and then get it flat and then do the rest. Install the 103 exclusion at RP1. There is literally towards the IC. Now that unfortunately didn't translate all that well, but this is the resistor package. There are, I believe there are 2, 4, 6, 8 resistors in here, and if you look at the back, you can see it goes from the controller to the LED panel. So it's just some inline resistance for that. And I'm trying to, again, they do have to go a particular way because one pin is common and the others are the resistor package. And as it says, there's literally towards the IC. That doesn't actually mean much, but if we look at the board itself, you can see, again, since we can see all the traces, this is a square pin or a square pad that doesn't seem to go anywhere beyond here, where these other pins lead off to where the display is going to be, which indicates to me that this hole, this outside one, is where the common lead will go, and on the package itself you can see a dot where the common lead goes. So sometimes, if it's not clear, if you just trace the circuit, you probably get a good idea of how things should actually go. Works for things like resistor packages like this, certainly works very well for if you want to make sure you've got a diode polarity right. You can see, take a quick look and see which direction positive and negative is. Now we'll put the 40-pin socket on for the controller. Now Got a couple ways to do this to support the socket while you're... Ooh, man. This has some seriously bent pins. Get some seriously bent pins like that. Take your needle nose pliers and straighten them out all at once so everything's parallel. Got a little notch here, and the notch goes towards the notch on the circuit board. So we put this in with unbent pins now. Now this is sticking flat to the board, so I'm not going to demonstrate the particular technique I have for that. I'll probably do it for the display. Let me get all 40 of these pins. That's the IC socket. Now we're going to put the controller in there, just 'cause. And got some bent pins here too. I'm going to press the pins against, all in one group, against the side of my workbench so they go in more straight. This is a very, oops, this pin came up. I don't know if you can see that. The pin came out of the socket a little bit. I'm going to try and push it, heat that up. Yeah, heat it up and pushed it with my thumbnail, and it went back in place. Now, notch to notch. All the notches line up correctly. And I think I may have to bend these pins a little bit more. And there we go. Double checking that no pin bent outwards while we were pushing things in, or inwards, or tucked under, and it did not. Now, we'll put the temperature sensor in, and the temperature sensor goes right here. And these pins are in line, they don't bend back one, but it is the same as the transistors. You want the flat side of the temperature sensor facing the flat side on the silk screening. And one more thing to do. We're going to put the display on. Now, as you can see here, there are decimal points or dots below the eighths, or number segments, and there's the corresponding dots on the silk screen. So again, it's easy to figure out how that goes on. Now that's a little loose, so when I do this, I rest the board and the component on my pinky finger, like so. And I tack one leg, solder one leg. Now I take a look at it, make sure everything's all flat to the board, and it is. So we don't have to do anything more with this. We can just go ahead and solder it all in place. And there it is, all put together. I'm going to pull this seal off the speaker. Everything's ready to go. So I'm going to turn off some lights and get some USB power run over here, and we'll fire this thing up. I've made sure the push button is out. Now we'll put the power connector in, and we'll press it, power it on. And it looks like, looks like that top number segment all the way along here is not working. I'm double checking my solder connections just to make sure. and everything is soldered correctly. This may be a bad part, but that's okay. I can figure out what it says. It says 22.6 degrees. Let's see what the buttons do. S1. Do a reset. There. That does... Oh, this is the upper limit temperature. So you can change that for your alarm. I'm decreasing it. So my upper limit is now 29 degrees C. And here's the lower limit. We'll put that at 10 degrees C. And that's what it does. I'm seeing if there's anything else interesting. Nope. So that's it. We're showing 21 degrees C. I'm going to bring my soldering iron close to it and see what it does. There you can see it running up. 27, 28, and there it hit my upper limit. Very nice. So that's a handy little thing. You may want to, I don't know, use it around the house, in your room, whatever. Let's do that again. There it goes, 28, 29. Just perfect. So it's a good little kit, except for the fact that we're missing the upper segments of that display. It happens sometimes. These things are inexpensive, and sometimes they use parts that have come from bad lots or whatever. But bottom line, it's a fun little kit, very easy to put together, does exactly what it says, and actually does something pretty useful. Another good one from DIngdong Shop. Hope you enjoyed the video.